Hello, everyone. We're in the exciting field of wastewater, right? How many are on a septic system? Oh, it's wonderful, isn't it? Well,
How many are dumping in a river?
so Craig built our MBR system back in 2018, 2019 for our new brewery. It's rated about 7,500 gallons a day, probably do a little bit more. It's interesting. We have a full-time person maintaining it right now. I mean, and we've slowly designed different things over the time, but technology has changed a lot faster. It's over like 7 years, so things have changed a little bit different. So we're still trying to get it up and going perfectly, but wastewater, it's like a living yeast, a living organism, and it's tough to control sometimes, foaming and everything else. But hopefully Craig here will figure it out for us and give us an update on how to do it perfectly.
Was that?
I threw a lot on his plate right away.
So the answer is 7.
Sure it's not 42?
No, I'm sure.
No, 67.
Is that metric or? So the idea today, we'll talk about brewery wastewater. And what I'm going to try to do is go relatively fast. So I'll go through what is wastewater. I'm hoping that's not going to be that interesting. Go through kind of strategies depending on where you're located. And then we'll go into technology options or ways to treat the wastewater. And then to what Paul was mentioning, things you need to consider when designing and operating a wastewater plant. So what I'll do is try to go through it relatively quickly so that we can then go back to the parts you found more interesting. So I don't want to stay too long on one section. So obviously, what is brewery wastewater? Well, it's any water in a brewery that goes from the well or the tap to the drain. So it could be hitting the floor and picking up some dust, which is a solid. It could be washing a vessel, picking up some organics. It could just be getting heated up, because technically heating water makes it wastewater, right? So anything that you do that changes the composition of the water that you take is effluent. That's just what it is. So the main ideas that we typically see, or the main reasons you're doing it, is because you have surcharges or compliance requirements on a sewer, or you don't have a sewer and you need to get rid of it. So you effectively have to build a wastewater treatment plant. So the question we get sometimes is, well, why do I have to treat my wastewater? I'm not doing anything bad to it. I'm making food, and unfortunately that's just not the way wastewater is considered. So the main drivers, and this isn't exhaustive, but the main reason that brewery wastewater is considered wastewater is, again, it's being transformed from potable to non-potable, but it's because you have cleaners, right? So you're doing cleaning activities, so that's putting dissolved chemicals into the water. You're changing the pH. So pH of human bodies and of domestic wastewater is around 6 to 7, 6 to 8. Caustic cleaners, acid cleaners, you could have a range of 3 to 12. But the main thing people typically talk about is BOD, so the biochemical oxygen demand of the water, so the carbon, so the fact that you've got a lot of sugars in the water. And what that does at any point in the environment is it is consuming the oxygen in the water. It's consuming the oxygen level. So if it does make its way to a stream, because ultimately, whether you're going to a sewer or you're going somewhere, it's going to make its way into a waterway. It'll consume the dissolved oxygen, it'll deplete the dissolved oxygen, and it will kill the species in the water. And if there's nutrients in that water, it will also cause things like algae bloom. I'm not going to get too much into that, but the main thing about the BOD is, again, we have high carbon loads in breweries or any food processors at all. And so domestic wastewater, most of your sewers are designed to take 300 milligrams per liter BOD, because that's what domestic wastewater is. Yours could be a north of 10,000. It could be, with side streaming, it could be 3,000. So managing that BOD load, if you're on a sewer, is to get it close to what your city can treat. And if you're not on a sewer, it's getting it to a point that you could safely discharge it into a field. So I just said the main items that we typically look at in wastewater is, and there's all sorts of parameters, but for this crowd, it's going to be the BOD, the biochemical oxygen demand, the organic material in the water. It'll be the solids, right? Settleable, total suspended solids. The drivers there are going to be grain, yeast, any solids. Why do people care about that on a sewer? Is because at the end of a conventional plant, after you've done the biological treatment, if you've done it, you have to take solids out of the water before you discharge. Certain solids that you have in your stream don't settle very well, like yeast. And so they can pass through a conventional clarifier and they can't treat that. So those are the two main items that they look at, and then followed closely by pH. So pH adjustment is, pH is one of the main issues you hear because, again, with the caustic cleaners, with the acid cleaners, you have a wide range. Beer obviously is acidic, caustic is obviously alkaline, but you have a wide range of pHs in a process. Biological treatment, as we'll get into later, requires a pH band of 6 to 8, right? I mean, you can talk about abnormalities, but it should be, textbook is 6 to 8. Most conventional wastewater treatment plants, they assume that domestic wastewater is going to come within that band because that's just on average how it comes down. They don't have pH adjustment. Most municipal plants don't have pH adjustment on their site. So if something comes in like a lot of caustic in a small town, they can't adjust and it'll kill their biology. They don't have the equipment to adjust. So that is a one big thing. If you have your own brewery, the pH will impact whether you can actually treat it because you have to have a biological band. The nutrients aren't that, the nutrients come up again and again because if you're discharging into a plant, they can handle the nutrient load usually because you're usually nutrient deficient. But nutrients are a hot topic because of the algae blooms. So if you get nitrogen, phosphorus is usually not that big an issue. We get large nitrogen levels, it can cause algae blooms. If you have a treatment plant on your own, you're going to have a problem balancing your nutrients because to do any biological treatment, you have to have a certain balance. It's just like your own body, you can't just live on Snickers bars. You need to have some carbon, some nitrogen. You need to have a bit of a balanced diet. If you're treating wastewater, you need to maintain a nutrient balance. So the nutrient issue is more a question of where you are, whether you're discharging to a sewer or not. I think because this talk is called Brewers Without Sewer. So is anybody on a sewer? Because I won't get into too much of that. Is anyone doing any wastewater treatment where they're discharging into a sewer, or is it all offsite?
I spread mine on a field.
So that's offsite, technically. Well, it's a sewer. Your field is a sewer, right?
It's my field.
Right. Yeah, exactly. Every field is a sewer now. So I say location. The only thing here is if you can find a sewer, sometimes that's the easiest thing to do because treating wastewater, like Paul was saying, is a job, right? There is an activity involved. It's not that you just send it to a piece of equipment and it's gone. It actually becomes work. So we'll skip that part. So rural areas, you don't have infrastructure, you don't have a sewer, you have to get the water, the effluent, into a condition that can be discharged, right? So what you're typically doing there is pre-treating the water to a level that could go to, let's just say a leach field, because that's what's happening, right? So if you had a house, you don't have a sewer, you build a septic tank, right? It's fine. Septic tank, leach field, you're good. Septic tanks are designed for human domestic wastewater, which is, as we went through it, a lot less strong. It's weaker. Sorry, that's the word. It's a weaker wastewater. So 300 milligrams per liter BOD is what a septic tank is designed for, actually 250. A brewery, as we saw, could easily be 10,000. If you're doing side stream, you could maybe get it down to 3,000. It doesn't matter. The septic tank's not going to work. So what you would typically do on an off-site application is you would, what's called pre-treatment, break down that BOD, take out majority of that BOD, polish it, and then discharge it. Some people might reuse that water. That's obviously a lot more, operation intensive, but you would normally pre-treat to reduce the strength so that you could discharge it through a conventional mean. So we'll skip the first one, because the first one assumes you're on a sewer and all you're trying to do is make a municipality happy. If you're not on a sewer, you've got to get rid of it, so you have to treat it to less than 30 milligrams per liter BOD, less than 30 milligrams per liter TSS, because that is what comes out of a septic tank. So you bring it to your septic tank will do some of the treatment, and the field will do the rest. That's your task. Your task is getting it to less than 30 BOD, less than 30 TSS, and then you go into a distribution field. That's how you do it. The way you do it is biological. Well, we'll skip. I don't want to go into one. Usually biological treatment. And the driver for that is you don't have a sewer. So that's pretty easy. So this, I will skip through this because this, again, is about if you're on a sewer. The first step in any treatment is primary treatment. So intercepting what you can intercept before it goes down the drain. Now, if you're not in a sewer, you're going to eventually do everything. But one of the things that you think of is, well, most wastewater treatment plants have some form of screening at the front, right? But most wastewater treatment plants are looking at domestic wastewater. So they got big bar screens to take out rags and stuff like that. You don't have that. You've got your floor drains. Those are going to take out usually the large stuff. What you're looking at in terms of solids for primary treatment is your yeast and your grains and shrub, like so the solid material from the plant. You can send it all down the drain in theory, right? But then you're making a trade-off. If you're not taking it out ahead, you're going to have to take it out downstream. Yeast, I think, is a perfect example. I'll actually let maybe Paul jump in on this a bit because I'm not a brewer. But when we look at yeast is the most problematic solid that you can put down the drain because it's an organism and it can create a lot of havoc in the downstream. We will typically recommend that you side stream that yeast because at the bottom of your fermentation vessel is a thickening tank, right? It is a thickening tank. So you can, in theory, take that out ahead of the treatment plant, and that will reduce a lot of your solids load and your BOD load. I know
the problem is it gets thrown onto the floor, it goes down the floor drain, and guess where it shows up?
Yeah, exactly, in the wastewater treatment plant.
Right.
I mean, one of the ways that I handled this and is, obviously solids-wise, at the end of spent stuff, everything's going to a pig farm, but the pig farm loves these.
Yeah, so I have a brewer in England. They take the yeast because it's acidic, and on that, their landlord owns a farm, and their farm they have blueberries. And so they take that yeast and they use it as an acidic compost. So there's sometimes a use for it, but it's like Paul's point is the interception, right? How do you stop it from going down the drain? And I think I wrestle with the point because I don't ever think it's an equipment thing. At a large scale, if you're at Molson Coors, they go through a DAF. So it goes through all to the drain, goes to a bubbling tank, it gets skimmed off the top and whatever. But if you're a smaller brewery, it's very manual. Or the other option is you can maybe use like a centrifuge to intercept.
We do that. Centrifuge and that pumps it into our side stream, but still, everybody knows when you're cleaning a tank or something, there's something on the bottom, it goes right on the floor, goes right on down into our wastewater, it starts foaming and the yeast starts. We try to kill it too with a little bit of chlorine, but then it's like egg whites. That's how it was explained to me. Part of it dies, but the other part then you stir that up and it gets fluffy, and then it makes our wastewater go crazy. So it's all over the place, and it's always on a weekend when it happens.
Of course. Yes.
And guess who's in there doing it? Because I'm there every freaking day.
Well, we always
I got
find
cameras in there too. They still don't have. I don't care.
we always find that if you can get the majority of the side stream, if you can get the majority of the yeast out, if your active biology is strong enough, you can overtake it. It's when a big slug goes. So that's what I put there. It's just the yeast is going to be the largest, and it's an SOP. It's how you get that done because the grain, as has been explained to me, that's already easily done in a brewery, separating the grain and that. But from the whirlpool and the trub, but the yeast is the main issue because not only is it a solid, it will have it will have big impacts on your biology, because when it gets to the downstream, it's in a perfect environment for yeast to grow, and then it takes over your bacteria population. So that's the main thing. So primary treatment, all I'm trying to say here is that in any treatment plant, one of the first things is screening. In your treatment plant, that's going to be the main issue, is how do you keep the yeast and any other solid, but how do you keep the solids out of the stream? Because ultimately with a treatment plant, what you're doing is you're using bacteria to treat organics. Bacteria will die. They will become a solid. You will be getting rid of solids at some point. So why introduce more solids into a plant when you're eventually going to have to get rid of solids, right? So back to that fermentation cone, you've already thickened it. Why dilute it to then thicken it again, right? So obviously you can't be 100%, but as much as you can get the solids out before, it will make your life easier. If you're on a small flow plant, if you're above 100,000 gallons per day, there are options, but on small flow, that's one of the trade-offs. So this is just to say,
That's where it happens.
yeah.
We all know. Right there. And you can put a bigger one, it doesn't matter. It still finds its way out.
Can't get a bigger man.
That's good, thank
Yeah.
you. Lady Brewers doing their job.
I mean,
We actually have a screw press as well. So
Really?
Yeah, we bought a screw press as well. And it wasn't that expensive. I got it from China. I buy all my stuff from China. Because I used to do business in China a lot, so.
as do we.
Samuel?
What's that?
I said, as do we.
Yes, yes. So, I noticed that this one company was importing, somebody, a brewery down in Florida, I saw the video and I looked, what's the name of that company on that thing? So I'm gonna contact them directly, and I got it shipped to us and paid for it for $24,000, for a screw press, and it works great too, but sometimes it's used too much.
Well, I was going to say that, but the screw press again is the solid at the end of the thing. So
Right.
it's at the end of the biological treatment.
Right.
So, but again, if the yeast goes down the drain, and if it doesn't create a foam party, and in a certain concentration it won't, but at too much it will. But if you get, it will eventually die. It will eventually become dead bacteria, and it will become sludge. And what is your cost to get rid of 10,000 gallons of sludge? So it's pretty expensive, isn't it?
Not anymore, because the septic, or both Lake George as well as Ticonderoga will take it.
Oh, so that's probably hence the press.
So, well, the press too, but on top of that, yeah, and it's usually it was costing us like $2,000 a month.
Okay.
But now, since I'm on 15 acres, we take it, and I asked the DEC as well as the health department, it's organic. They didn't care what the hell I did with it.
Yeah, you land apply.
So, water across the street, I have big holes, I fill it up with sand, because we're a sand pit around there, and I just keep mixing it up there, and sooner or later it's gonna be nice compost, so, you know, that's,
So you have a farm coming.
yeah.
Stay tuned.
Please, I don't need any more projects, please. That's like-
So the hobby farm. No. So let's skip over that. So the primary treatment is something you're going to do no matter what. So if you're on a sewer, not in a sewer, you should do the primary treatment. But if you have as we discussed, we're not on sewers here, so we're going to do the primary treatment, which is getting rid of the solids, getting rid of anything that can upset the biology, because you can't get rid of it. Unlike if you're on a sewer and you know you're not supposed to flush it, but it's not your problem anymore, it's your problem, because it's going to be your problem. It's going to be your problem upstream or downstream.
I did see back 5 or 6 years ago, a proposal by the DEC about going after breweries going down into a sewer. And it will happen one day. It
Oh,
just
yeah.
takes a long time, and they're gonna have you put a monitoring system on it and everything else to make sure of it, so.
Well, I'm talking to a brewery right now in South Carolina who's convinced that they are not going to have to treat for pH, even though the letter they got said they're going to have to treat for pH. And I think every brewery, whether it's not on is going to have to adjust for pH, because pH swings. If you go in at 11 and you swing up the biology, their system won't work. So yeah, it would happen. I don't know when, but like you said.
Do they find it easier to deal with that with chemicals or with dilution?
Well, the problem is municipals, as might shock, the municipal wastewater treatment plants haven't changed a lot in like 80 years. And so they never did any pH adjustment typically, because again, domestic wastewater comes out at 6 to 8, right? Our bodies, right? Comes out 6 to 8. And that's where activated sludge traditionally has its pH band, and industrial users on the grid have always been required to pre-treat, like since the EPA, whatever. But so it was always kind of taken that for you to connect to a sewer, you have to well, they don't care how you do it usually, you have to get domestic strength, which means 300, and pH range, and there's certain things, because what they're trying to say is, as long as you give us the water in the condition of domestic wastewater, we'll treat it, right? They don't usually have the ability to handle pH, but some places might, and then they wouldn't care. Or you could be such a small drop that it won't. Like we have a project in Middleton, New York, where it's like 2,000 gallons per day. And like it's not going to move the needle at the downstream wastewater plant, but they still have to pH correct for their permit. It's usually the easiest, so it's hard to argue, because you can also just do it with a large buffer tank. Because if you have a large enough tank, brewery wastewater, in my experience, on average, is close to 5. So that's not a big jump from 6. So you could just have a big tank. So the main ways you do treatment, so to get the BOD out, to reduce the BOD, the main mechanisms, and to not bias one way or the other, you have anaerobic digestion, you have aerobic digestion, and advanced oxidation. You're not going to do the first or the third, because anaerobic digestion is very expensive and very complex. A long time ago, many years ago, my previous career, I did do a little bit of work at a Molson Coors plant, and they would use an anaerobic digester because they had such massive volumes. The anaerobic digester would knock down the BOD to, say, 90%, and then they would polish with an aerobic system. But they're very complicated, because if you make a problem with anaerobic digestion, you could have an explosion, right? So it's a much more regulated issue. You're not, at your volumes, you're not creating enough energy to make it worthwhile. But it is a way to have a microorganism population that will break down your BOD. Aerobic digestion is what you will, in some form of that, is what you're going to create. You're going to create an aerated environment where bacteria will form to consume your carbon. The most common is activated sludge, but we'll go through that. There's others. And then there's advanced oxidation. I just put that up for completeness. That's using chemicals to oxidize the compounds and take the carbon out. So it could be hydrogen peroxide, ozone. That is something you do in the pharmaceutical environment, where there's something funky in that water that will also kill biology. So you got to take out you can't use biology because it's so toxic. That's what you use. So what you'll be using is some form of aerobic digestion. Aerobic digestion is the most commonly used form of treatment in the world. So if you are on a central sewer or close to one, or have a friend who works at one, that's what it is. It's activated sludge. It was invented in 1913 in England, and it was there as it was an experiment. It was an accident. They were bubbling air into a tank, and they found that it formed a bacteria culture that consumed the wastewater. And that bacteria form, what they'll typically do is they'll culture that bacteria in what's called a bioreactor. They'll feed it oxygen. Your sewage is its food, so it's getting oxygen to survive like you need it, but getting the food from your sewage. And then the trick is in the clarification step, because after you've pre-treated, you do your biological digestion, your wastewater treatment plant, and then you got to keep that bacteria in the system. I think similar to your brewing process, you got to keep that bacteria in the system so it can go and treat future wastewater. So you have some form of clarification where you separate that treated water where the carbon has been taken out by the bacteria, and you take the bacteria back to the front, and you take the treated water and discharge it to wherever you want. In your case, it's going to be a leach field, but that's, in a nutshell, how aerobic treatment works. Their main issue at a domestic plant is we produce more nutrients than a typical bug bacteria will require to live. So we have excess nitrogen, excess phosphorus in our wastewater, and bacteria won't consume all that. So your downstream plant will be a little bit more sophisticated, because it's going to be trying to remove nitrogen excess of what the bacteria will remove normally. Your issue, if you have biological treatment, is you'll have too little nitrogen. So you'll be trying to supplement the nitrogen in your system so that it will function properly. And so while they might have a perfectly functioning bioreactor downstream, but they have too much nitrogen going out, you might have a poorly functioning bioreactor because you have too little nitrogen in it. But when it all said and done, it's the same system. It's the same idea. You've got bacteria culture, which you're going to breed and build up in a bioreactor to break down your organics. If you're looking at systems, one thing, just a tip, obviously, you want to know what you're getting, right? So there are probably 4 forms of aerobic systems. So whether it's a whatever company or this company, you want to try to find out what it is. It's either going to be activated sludge, SBR, sequencing batch reactor, which you see here, moving bed biofilm reactor, MBBR, or an MBR. Those are the 4 common things. So I only put that up there. So if you're doing your research, I would say those are the most commonly used technologies. They'll all work. They can all do it. They all have pros and cons. I would say the one we do is probably used a lot for high strength, but so is MBBR. There's a lot of, I'm not going to say one's better or different, it's just how you operate it. But ultimately what it is you're creating a bacteria population that's going to treat your wastewater. And they have different mechanisms of action. The first 3 is a fluidized bed reactor. So it's just in suspension, a big tank. It looks like almost chocolate milk, getting bubbled, and the bacteria are forming and getting thicker and eating the food. Moving bed bioreactor is they all grow on the surface of a media. It's still bacteria. It's the same idea. And if you don't give it food, your carbon, and you don't give it nutrients, it's not going to process. And then once it's processed, you're not going to be able to discharge unless you can find some way to separate that bacteria from the water. Conventionally, that's done with gravity. So this is what's called an SBR, and it's very similar to an activated sludge, a conventional plant. What would follow this treatment train is a large tank where you would let the bacteria settle out, and you would have a pump at the bottom and send it back to the front. And you discharge your clarified water. The technology we use is an MBR, but it's the same idea. Instead of settling, we use a filter, but this is a process flow. This is a project we did in England. So it's a process flow. It's a very small project, but it can give you an idea. And any treatment you do, it's going to be some version of this. So like we said at the beginning, you're going to start with pre-treatment. You're going to condition that wastewater into a form that it can be biologically digested, balancing out the flow. If you have a big dump of water, you don't necessarily want to size a massive plant, so you want to have a balancing tank. You want to pH adjust it, so you adjust it in a form that it can be biologically digested, 6 to 8. You might add nutrients. This plant is on a river, so they have mapped all their nutrients, and they've got an auto feeder, and then they just come in and fine tune it. But you put your nutrients in, that's your pre-treatment. You're conditioning the water into a form that can be digested. Then you got your biological reactor. This is where you're going to culture the bacteria. You got to keep that, in suspension. You got to keep enough air in there. You got to look at it like a pet, like a fish, right? Some pet that gives you no gratification. So you got to keep it alive, right? So you're going to try to make sure you got enough food in there, enough air in there. You can name it. No, you can just keep it healthy. And the way you tell with it is the color of the water. It's chocolatey brown smell. And then you're going to filter it, or you're going to clarify it with a clarifier. But that's your process. At this point, that would be a process train that should let you go into a surface leach field. So if this was any other plant, this would still exist, it'd just be a clarifier. But the same process, I'm just trying to say that the process steps are the same no matter what you're doing. You're effectively pre-treating, digesting, clarifying, getting rid of it.
Could you clarify some of the distinctions between surface discharge and leach field discharge?
Yeah, well, surface discharge is going to be a little harder for you to do, I'll be very honest, because when you're going into surface discharge, what they want, actually, because we're doing a lot of these in New York right now for land development, is you have to have a low BOD, and you can design for that and you can operate for that. You have to have a good pH, because they want it to be 6 to 8, so you should have that anyway. But what will be your problem is ammonia. Because if you're going to go into a stream, they're worried about the ammonia levels because it's toxic to the aquatic life forms. And your systems, like I mentioned, you're going to have to nutrient dose. So if you can design a system where you are really fine-tuning your nutrient dosing so that you can keep your ammonia level below 1 milligram per liter, in theory you could go out. But for a small plant, you're probably going to just overdose here and there. And so your ammonia levels are going to be a little higher than, because in theory you could keep it at 1, but in practical reality you're probably going to try to hit a target of 10 milligrams per liter ammonia. That won't be sufficient for discharging to a surface. So that would, I think, be your issue if you wanted to do surface discharge. It's possible, but you also have to look at the reality, and we'll get to the next slide, of how you're going to operate it yourself. Surface discharge, subsurface discharge is more forgiving, right? You're typically hitting a total nitrogen target. And so then you can fine tune your ammonia to stay with under 8, which is really low for total nitrogen, and that might be more acceptable, easier. Now, it does take a lot of land to get rid of it, but that would be the main thing. One project we did do, which might be of interest if you're on a new project, is that they're taking the water from the brewery, treating it, and using it to flush the toilets at the front end of the front of house, so that you only create one leach field. Because the brewery, in this situation, it's a small brewery, the brewery water is less than they're using to flush the toilets in the restaurant and all that stuff. That's one option that lets you reduce your leach field. It wouldn't go to surface, but that would be one way to reduce your leach field.
The word surface discharge requires a permit.
Oh yeah, and then that permit is, that's what I'm trying to say, the ammonia level is, that's why I just don't think it's going to happen.
Fines are a lot, because Empire was fined a lot of money.
I wouldn't do it. Like, I really wouldn't do it. Like I was trying to say, I wouldn't do it. The only way I would do it here, sorry,
No, in long term, there's a lot of breweries got in a lot of trouble for surface discharge.
is, yeah. Well, it could be the beer.
Surface discharge, yeah.
Unpermitted, yeah, I know.
Well, because like usually the beer, so they'll, if you do surface discharge, because in an intermittent stream in New York, you'll have a BOD level, you have a TSS level, you'll have a lot of levels, but you'll have a pH level, and then they'll have a total ammonia nitrogen level. The BOD and the TSS, you can filter it, right? So you can get the TSS down. The BOD, you can digest it, right? The ammonia would be the main issue you would have, where I would say, I mean, if you're not treating it, you're going to blow every single limit. But even if you had a good operating plant, I think your problem would still be ammonia. You would, and I don't even know what you would do to pre-treat that. To get down to 1 milligram per liter, you need some sort of like RO filter or something you don't really want to get into. So I don't think it's viable, really. All right, so like I said, this is that's how we do filtration with membranes, but there are different ways. This is a filter to keep the bacteria in. And then back to what Paul was saying, I was saying too, that the other thing you have to remember is that if it is a treatment plant, there are things you're going to have to do. So it is, well, you said a full-time person, I always say at least a few hours a day. So there is somebody who's going to have to, it's not something you can not do, right? It's not somebody it's not something you can avoid, because unlike a biological system, so I have a system in California, I was just talking to him today, he goes once a month. Once a month, that's all he does. He does everything remote monitoring, and he can do that because of the nutrient dosing. The main issue you will have in an industrial application is that it's not an average. Humans are humans, so you fill a 300-room hotel, you got 300 people more or less behaving the same, more or less producing a homogenized wastewater. You can get that in steady state, and then just start reacting to the inputs you're getting from remote monitoring. An industrial wastewater plant, you have to be cognizant of the fact that your pH can be off. You have to keep the biology healthy, right? So your nutrients, like I was saying before, like you cannot assume that you can assume you're gonna give it a lot of sugar, but you can't assume you're gonna give it everything else. So you have to keep an eye on the diet. You can do that either daily testing, or you can spend the time to build a bit of a baseline of what your actual nutrient imbalance is. But that some way you're going to have to develop a bit of a diet on your nutrients. You have to monitor your biomass, right? Healthy versus unhealthy, because shock loads, you could have a cleaning incident, you could have something that's going to impact. Industrial is a completely different thing, so you have to look at it daily. And then on top of that, so that's just the biology, it's just mechanical equipment. Pumps go, blowers go, filters clog, right? Somebody's got to be able to ready to check that, keep an eye on that. It's a job.
I mean, cleaning the tank and cleaning some other tank and pacifying some other tank and get all the chemicals in there, and somebody's got to be there to make sure it's adjusted correctly.
Yeah.
It's a full-time job for us.
Yeah. But is Joshua full-time on the plant, or does he do other stuff too?
He'll help with me.
Yeah.
But most of the time he's in the sticky place.
Yeah. Well, like the project I was talking about in England, they got a guy, he's 3 hours of his day, every day. 3 hours of his day is on the plant.
It is feasible for smaller scale with fair amounts to do it. That's part of our routine. Like we use it for maybe a couple hours a day.
Well, Steve, so that we have a winery in Lake Erie, and so he only brought in someone before. So that's about 2,000 gallons per day. So it's not that big a wastewater treatment plant. And he's the one who I set up the auto feeder. So he did a lot of analysis on his nutrient loads, and he just put in a baseline auto feeder to do the top up of the nitrogen, and then he would come in once at the end of the day and check the ammonia levels. You can, in theory, figure it out, but you can do it at a smaller scale. I guess what I'm trying to say is that you're still going to have to do some work on it in terms of the maintenance, but as far as the biology, I mean, the bacteria, you could do a 100 liter per day wastewater treatment plant, right? Because you can build that down. It's just the reason people typically don't do them too small is that at a certain level, it's cheaper just to haul it, if you can haul it.
Right. I mean, I just mean in a sense of like bringing in a third party versus trying to make it part of our everyday workload.
The only way I've ever seen a third party work, so I think it'd be very expensive to hire a third party operator to operate your plant, because I had someone who had if they had a pH probe go off, they'd bring someone into. I think you have to learn how to do some of that stuff or do it yourself, but your permitting sometimes is required. Right? Like I operate a wastewater plant. I operate a plant in St. Kitts. I go down. Yeah, it's an interesting gig I have, but I can do it, right? If I can do it, anyone can do it. But there's certain things you have, like it becomes like you have to stay on top of your operation checklist, right? But it's, you've got pumps will pump. Pumps have to be pulled every 6 months. You can pull them every 2 years, but you're supposed to pull them every 6 months. There are certain things that you have to do. An aeration filter, so there's mechanical stuff you have to do. The biology will digest, but it will only digest if it's kept in the proper conditions. Now, if you put a lot of caustic down the drain, it's going to spike your pH. So your options are you automate the regulation of that, or you do the manual correction of that. Both can work. I have people who do both, but you just it's just the reality. There's certain processes, like parameters you have to maintain to keep the biology healthy, but it can be done. What size of application are you talking about?
I think you built your system last in Brewery.
Oh yeah.
I think we're like a 6,000 or 3,000.
That one was designed for 2,000 gallons.
2,000.
So that was 2,000 gallons with an EQ tank for 2,000 and a biological reactor for 5,000 gallons.
Right.
But that system is, I think it was designed to get built up to a larger flow, like it could add more. But my only point is that it can all scale and it can be done at any size. But the main things are you're sizing your plant based off of your your biological load.
Right.
So if you have, because if you do biological design, it's X kilograms of biology, of BOD, requires this much time to digest, so many hours of, right, and this much oxygen. So you can scale that at any size. So if you're going to have a higher load, you need more digestion. You have lower load, you need less digestion. Same as the nutrients. The nutrients scale directly to the carbon. If you have, I think it's 105 to 1. I don't know if that's actually correct, but you need to dose your nutrients based off of the carbon load. So everything will scale, but that's what I'm trying to say. It's not a button you can push because you have to design the program around it.
We've been slowly updating ours. We put diffusers in there with a vortex generator, high, low CFMs, high CFMs, low pressure, into diffusers in each one of the tanks. And then we took the pumps out of it because they just kept failing and they're so expensive because the chemicals were just eating them up. And right now I have some mixers coming in from China now. All they are is 3-phase electric motors with propellers on them with a thing so we can hit that wall because we have 3 10,000-gallon tanks just to mix that up on top of it. And we still have issues, and Craig knows our issues too, but we're trying to modernize it and get it more up to date. So because our pH is all over the place, because it's not being mixed up well enough, and I just can't see buying $5,000 pumps every 6 months because they're getting a little expensive. Our chemicals must have been really strong because they were eating up those pumps. They're eating up our pumps.
Well, I was there about 2 weeks ago, and the bioreactor was at 4.
Yeah.
And that's what I was talking to Josh. Like, again, academically, you're not supposed to get any biological activity outside of 6 and 8. Now, I looked at the permeate; it was clear. So you are culturing a bacteria that can exist at 4, apparently. But it will eat. But all pumps are cast iron. I'm going to back to first principle. The pumps are cast iron. Cast iron will get eaten away below 5. So those are your process parameters that you have to. Because if you go below 4, you might create biology, but then what pump material? Like the banks, like the submersible pumps, which are 304 and the FRP, they'll survive, but all the aerators are going to be cast. They'll get like you said, eaten away.
Yeah, they're eaten.
Yeah.
And you got to remember, Josh was a lot more adamant about making it work correctly.
Yeah.
And the other guy was just.
Yeah. No. Yeah.
So we sent them to school, but this guy's now really serious about it. We have charts and everything.
Yeah.
So I think we're going to get it together finally.
I would think so, but
Years.
but I would say it's your dissolved oxygen, it's your airflow, right? And your airflow keeps your dissolved oxygen, right? And again, why are you keeping dissolved oxygen? Because you need 2 milligrams per liter for your biology. You need a pH of 6 to 8 for your biology. You need a nutrient level of above X for your body. So that's what we're talking to Jack, because he's a data guy. You got to stay on top of that data, because if you stay on top of that data and you keep that, you're going to keep the bacteria alive. If the bacteria is alive, it'll do its work. If it's dead, it's not going to do anything, right? That's the main thing. And it is a more complicated stream than sanitary, simply because usually you don't put caustic soda down your toilet, right? Usually. I mean, everyone's different. But. I was
I don't know so much about wastewater.
You drink it, you drink it. I mean, it's just not.
Any other questions about?
We moved our brewing operation to a municipal, but we're still pouring beer down our drains a lot,
Yeah.
and it's causing a big issue to our septic system.
But I thought you said you were on a municipal.
At the original one. At the original one.
Oh, okay.
2 locations, so.
Yeah.
The original one still is there, no more brewing, but, gallons of beer going down that drain
To your septic.
into our septic.
So
It's like sugar and.
Correct, yes.
Yes.
So, every time I dig it up,
Well, so beer is 60,000 milligrams per liter BOD. Obviously, a Helles lager is less than a double IPA, but it's a lot of BOD.
I'm not dealing with particles, but I have way more issues.
Well, you are, because the sugar will eventually create bacteria, and that bacteria will become a particle. Short answer, no, you can't put beer into a septic tank.
Right.
Your only option is to haul it as trade waste.
Ag and market search.
There is a company.
Say you can't.
There's a company called Generation Upcycle you could look into, or companies like Generation Upcycle. They run anaerobic digesters.
Yeah.
So if you have a steady stream of this, and they can characterize it, right? Because it's a fuel.
Yeah.
They will take it from you, and they may even pay you for it.
Well, interesting.
Yeah, they probably won't pay you for it, but they probably won't pay you to take it. But what I think they require is that you can tell them what it is. You can give them some sort of predictability of it, right? Because obviously they don't want to take it once a week, one month, and 6 months later. Because they have anaerobic digesters, and usually anaerobic digesters have some issue getting fuel stock, and they're either want more wet wastewater or more dry waste. So they try to pair you with a digester. There was one in Ithaca that used to take a lot.
Gore Mountain takes our can in the summertime because they don't have enough BODs because.
Yeah.
So they go and they keep one of those cans and crush them and dump them into it. Just fine, so we just keep putting them out of cold beer in the corner there.
I used to live outside of Rotterdam in the Netherlands, and they overbuilt their wastewater treatment plant, and they would come and find plants, and there was always a kind of a game the plants would play where they would start threatening to treat their wastewater because Rotterdam was overbuilt, they needed carbon. So sometimes, some people need it.
See, I'm threatening to treat their wastewater. That's one of the things I've been thinking about the anaerobic. I'm currently small enough that I'm paid to have it hauled away.
Yeah.
But for a brief period of time, I tried to set up some anaerobic, and then rapidly discovered anaerobic is so unkind to my neighbors.
Yeah, it stinks. It's called methane.
It stinks
also a bad way to make friends.
Badly that it's like, okay, this cannot be,
So what we did with ours too, because our really stinks, especially during the summer, we covered up, we have 3 10,000-gallon tanks in the ground. We covered up the top of it, and then we put some suction fans, like from Wastewater, that go on it. And it runs outside, goes down across the road into a big pit that's about 10 feet deep, and with almost like a septic system covered.
Like carbon?
Yeah, the plastic is on there. And then we fill it with wood chips, right? And we keep it wet. And we're supposed to put peat moss on it, but we got it done right before it was snowing, so it still stinks. You put the peat moss on top of it, you keep that wet because we have a sprinkler for the summertime, and it does take the smell away. It should take the smell away. I know it's working because you walk outside by it, and there's no snow on it.
Well, it's the methane, right? The methane is what creates the smell. So if you can vent the methane or scrub the methane, right? Don't flare it. Please. But that's what creates the scent. That's why a functioning aerobic plant should not create smell, because what you're doing is like you said, the bacteria is consuming your carbon. You're putting in dissolved oxygen, and it's expiring CO2, so it's sort of scentless, right? But an anaerobic system is creating methane, which doesn't smell nice.
We're trying to get
Air.
We will, but we got to get all mixed.
Yeah.
It'll be 10 years before we do. None of us are chemists or something.
No,
Yeah.
Well, you are chemists, and you do culture bacteria.
Yeah, those guys. And they don't give one crap what they put down the drain. That's the problem too. You set up rules and everything else, it just,
Yeah.
how do you stop a lot of it? They're trying to move tanks and trying to get the beer out, so.
Well, the only thing with the yeast is the pre-treatment. Like the screen that you're going to put in, I think will have some, because you can settle it out, and a larger plant will do flotation. But then a DAF is just as complicated to run it, so you got 2 treatment plants. So it it is intensive.
Because Brewers is so, unstable in what they put down the drain all the time. It changes
Yeah.
constantly, so it's really hard to maintain it.
Well, I would say like if you have a thick biological, if you have a healthy biological population, you can go a few days without putting stuff down. It's more of the upset. Like if you can avoid upsetting it, right? If you can, like if you have a thick biomass, it can take a few days without food. It'll eat each other. But if you the yeast down, or you just hit it with a slug of 10 pH to kill everything, then it takes a while for it to upset. And then when it upsets, you get the foam, right?
Yeah.
So, yeah, it is, like you said, it's work. You know, it is a system that you have to maintain. So it is a trade-off, right? Being on a sewer, the land might be more expensive, it might be more whatever, but you're running a utility.
That's what you get for looking over the mountains with a beautiful view. With a smell.
Sounds like it has its compensations.
Any other questions, or I mean, where we are? Oh, good, we still got time.
If we're having like we just have an addition, basically.
Yeah.
So should we take different considerations when there's like some?
Yeah, fats, oils, and grease.
Yeah, exactly.
So fats, oil, and grease. So for MBR, absolutely, because the fats, oil, and grease will clog the membranes. So you have to have a grease trap. And then the fats, oil, and grease are a huge spike of BOD. So your fats, oil, and grease will spike your BOD, so it may tax the limits of your aerobic reactor. And the fats, oils, and grease, if you have an MBR, will coat your membranes. Or if they go to a clarifier, as you know, it floats. So fog you always have to remove. And then the other thing to consider is that people pour alcohol down the drain, which is a crime, but they do it, and that is really high BOD. So if you're gonna pour alcohol down the drain, you want to meter it down, because if you put a whole bunch one day, because we did a project, it's not the same, but it's similar. We have a project in California where they do four weddings a week on the weekend, and sometimes they're just pouring alcohol down the drain at the end of a shift, and we're like, no, do that on Monday.
Our tasting room drains are connected to the wastewater.
Yeah, so that.
Problem with that also too, because dishwashing all the time, just keep going up with water.
Yeah. So if you can meter that in, sometimes that will help, because it's high depending on the volume, right? And you can do the math. If it's alcohol, it's 100,000 milligrams per liter. You can then equate how many liters it's going to take to get to your 3,000 milligram per liter of loading. But what we did at that, it's called the Inn at Maddie's Tavern in California. What they did is it goes into a little tank, and a little 1/4-inch line, and it just slowly drips in. That's what they were. That's what worked for them. Pour it in that tank, not that drain. And then the fog tank was that was the fun one, because we were like, why is it foaming? And it's foaming like crazy, and no one's friends when it's foaming. And then we went and inspected the grease trap, and we said, well, you just bypassed it. And they said, yeah, if I bypass it, I don't have to empty it, which is fair, but also fucks up the plant. So yeah, it's the trade-offs, right? It's trade-offs.
Who's hauling away your grease? Because we can't find people to haul away our grease anymore, so we gotta buy a very sophisticated grease trap. So I would think about that too. I have one of these $4,000 grease trap now that actually it goes through a process and it heats it up at night, and then it floats to the top, and then this little wheel goes on and it dumps it into a container. And every day you just pick up the container and dump it into your French fry oil or grease. Not that way. That thing works great. It saves a lot of money, and it's definitely worth $4,000. And
What do you do with your grease? You just recycle it, or?
okay.
Yeah. Oh, you mean you dispose of it as solid waste at that point? Yeah.
Solid waste, yeah.
We get it picked up, somebody pays, we give it to our neighbor restaurant, and then they get paid to put in pays for it.
Yeah, we have one of those for the French fry, where we just pour it
Yeah.
down into there,
Okay.
into it, the same thing. But the same, it's, you know,
I sense,
depends how busy you are. It has a little thing on time, just pull it off, and then you have to clean it every quarter, go in there and clean the inside of it. But that works pretty good, guys. I'll tell you, compared to the other grease traps, we're not working that great. Because I went out into, took the lid off of one of our tanks out there, and it was just filled with grease. You know.
I
And
s-
the problem is you can't get people to always clean the grease trap. You know, they forget about it, out of mind, out of sight. This way the thing pulls up and alarm will go off.
could be the start of a biofuels business. Come on, just, you got the farm, you got the farm, you got the biofuel. Yeah, I mean, I don't have anything else on the wastewater, but any other questions or? Nope. Well, yeah. Well, thanks for coming.
Thanks, Fred.
Yeah.
Thank